Take 2. As you can see, we're going to add, subtract, multiply, and divide functions. Okay? And as we're looking at that, we're also going to be looking at composing and decomposing, and that'll be the end of today. I'm not even sure if we'll get to decomposing. The decomposing is the simplest combination of 2 functions that would be composed together, and we just take them apart and come up with the simplest. Okay. Then tomorrow, we're going to identify the domain of the new functions. Well, we'll identify the names of the new functions today. And tomorrow, we'll find implicitly defined functions. We'll work with them. Okay. As we're going through, let's go to this next thing. So knowing how a function is put together is an important first step when applying tools of calculus. So how can we put functions together? We can combine by adding, subtracting, multiplying, dividing. Here's what we can do. When we have the sum of 2 functions, let f and g be the 2 functions with intersecting domains, then for all values of x in the intersection, the algebraic combination of f and g are defined by the following rules. Now, they're talking about intersecting domains, okay? Have you guys gone out with somebody and although your mom and dad say, hey, you know, you're fine, you can stay out until X time, the friend that you're going out with has a more restrictive time limit that they can be out? Have you experienced this? Okay, that's what this idea of the domain of the functions that we're going to create is. Think about when you find the 2 domains, you're considering the times that you can be out. Okay, but when you're looking at the domain when they're composed together, whether we're adding, subtracting, multiplying, dividing, or even composing them, we're looking at the most restrictive domain, okay? And we're comparing that with the domain of that new function, okay? So we're going to add them. We're going to find their difference. We're going to do the product, which is multiplying. We're going to do the quotient with, the Q word, which is dividing as we go through. In each case, the domain of the new function consists of all numbers that belong to both the domain of f and the domain of g. As noted, the zeros of the denominator are excluded from the domain of the quotient. This is what the book and Slater do. We don't. I expect to see the zeros. Matter of fact, scratch that out. Get rid of that statement because we will denote the zeros in our domain, okay? Because I'm expecting to see it. Left in there just to make this point about those 2 resources, okay? That's why I don't post the book answers, okay? Now, as we're going on, let's talk about the different things we can do. Now, D sub f, that capital D sub f, is the domain of the f function. So if I'm looking at f, I mean, I've got f right there. That's f of x is x squared. I mean, what's the domain? If I'm looking at that, that's a parabola, and its domain from negative infinity to infinity, everything works, right? So I'm looking at a domain here for f, and I'm talking about my parabolic domain. Maybe perhaps I can do this and that. My domain is from negative infinity to infinity, right? I'm not talking about the rim. I'm talking about the domain of f. Now, if I'm talking about the domain of g, or my function g, you got to keep in mind what this looks like, okay, as I do this. Now, this is the square root function, okay? The square root function doesn't have anything below 0, at least underneath here. I can't have this. I mean, I can have that be 0, but it can't be below 0, okay? Which would be kind of nice if you think about temperatures, but I digress. But if we're looking at this, I'm looking at it 1 unit to the left, but it starts here and takes off like that. So that's my function that I'm working on with the domain. So my domain is actually that x plus 1 has got to be greater than or equal to 0 because it's in the numerator section, not the denominator. If it was in the denominator, x plus 1 has got to be greater than 0. Okay? But in this case, my domain would be negative 1 to infinity because if I subtracted that, that's what it is. And are there any questions about it? Now, which one's more restrictive? Yeah, shoot. Domain of G. Okay, so that's the one that's going to kind of, if I'm going out with, function f and function g go out on the town, well, gosh, g's totally making it happen. It's a big bummer, but g's timing has to restrict us what we can do. Okay, so keep that in mind. That's the most restrictive, and if it's in the functions at the time, we have to consider that. So f plus g, as I'm doing that, I'm going to say, well, I got f, x squared. I've got g, x plus 1. So I put those in, and it's just that straight up. X squared plus the square root of x minus 1, or plus 1, excuse me. Now, x squared, negative infinity to infinity. But if I have this together, this one drives my issues, right? Because it can only be from negative 1 to infinity. So if I'm asking for the domain here of this function, the domain of f and g put together, if I'm adding, is from negative 1 and including negative 1 to infinity. Does that make sense? Now, same idea with f subtract g of x. You guys come up with the restriction on your domain as we go through. And go ahead, after you do f minus g, do f times g, just for fun, and compare with somebody around you as you go through it. Compare with somebody around you as you go through it. So if I subtract, I've got x squared minus the square root of x plus 1. I still have that restriction that the square root of x plus 1 brings with it as my domain. Okay? Although in x squared is very loose and you can do anything outside of that negative 1 to the left of it. Because of that square root, I've been restricted in what I can do. Okay? And f times g, the same idea as I'm multiplying. Okay? Again, this function, when I'm looking here, this is still driving my restriction. X squared could be anything. But it's the x plus 1 that's driving my domain choices. Now, because x plus 1, that square root of x plus 1, is in the numerator area, not in the denominator and not below, you got to keep in mind that I can include negative 1 with it. Okay? Because it can be 0. That's okay. But when I'm doing the f divided by g function, and this is where it gets sneaky, okay? Because we've been doing this the whole time. I want to make sure you recognize that since I'm dividing, this is no longer okay to be 0. Okay? So now I can't say I can include 0. It's not greater than or equal to or less than or equal to when I consider my domain. And keep in mind, x plus 1, if I'm considering my domain, has to be greater than 0 here. And that's why I dropped the bracket around my negative 1, because it can't be equal to negative 1. Okay? Now, I want you guys to try a combination of g times g. Remember that double g is the function g times g. Okay? And we're going to be doing compositions, and this is the best for me showing that I'm multiplying g times itself. Okay? So think about what's going on when I think about function g. Function g is the square root of x plus 1. So I'm asking you to multiply the square root of x plus 1 times the square root of x plus 1. Are you okay with what I've got there as I'm stepping through that? Now, keep in mind when I'm looking at this composition, or this multiplication, I should say, I get x plus 1. That's a linear relationship, okay? In and of itself, x plus 1, if I had a function, f of x, x plus 1, well, geez, from left to right, it would be defined in its domain from negative infinity to infinity. But because it was made by g of x, which has that restrictions, this function's coming with certain restrictions, right? So my domain here, although I have x plus 1, my domain is from negative 1 and including negative 1 to infinity. And I've got people that are looking at, yeah, but this works for everything. It does, but it's restricted by the functions that created it, okay? You got to keep that in mind as you're making these. Questions? Doing okay on these restrictions? I know it's something you've seen before, and I want to make sure it's clear. Me going through faster doesn't help people with clarification. Doing all right? Okay. Sliding on to this next question we have for examples. Now, I would like you to try one. Okay. Find the domain of F and find the domain of G separately. And then, because, you know, this stuff is something that just sits up and doesn't even save for Bloom. Let's see if we can do this as, let's try that again. Let's hide that again. Hey, let's see if that worked. Hey, that does. Okay, well, let's leave that open for you guys. Find the domain of F, find the domain of G. Do it on your own, and I'm just looking at it. What's the restrictions for F? What's the restrictions for G? And write them in interval notation, okay, to see where it's at. I want the notation to be seemingly friendly for you. Okay, sometimes people look at that interval notation, it's like, ooh, it's mysticism altogether. Cheap seats back here. So here we go. Are you okay that from negative infinity to 3, and from 3 to infinity, I've got this going on? Because I just have x can't be 3 there. You okay with that? X can't be 3, so I should have that restriction, okay, with that non-removable discontinuity, that vertical asymptote. And then I'm looking at G, and I've got to consider the fact that x has got to be greater than or equal to 0. So as I'm going through there, you okay with that restriction for my domain? Questions? Now, when I'm adding these, I'm going to have you guys go through. I just want you to have to do A, do the B, do C, then we'll talk about them periodically. We'll do A, we'll give you 30 seconds to try to get it done. I want you to practice them. It's the same stuff we're going to do on the assignment, and I figure if you get it here, it'll make the assignment will seem more like a review. Remember, we're just adding the functions together. Remember the notation here, we're adding, subtracting, multiplying, dividing the functions. Adding, subtracting, multiplying, dividing the functions. Stay warm. Remember, as I'm doing this, I have f of x plus g of x, and f of x is 1 over x plus minus 3, and plus x. My restriction is right here, but I can't have 3 be part of my function. So although my g was from 0 to infinity, the thing that's driving my restriction to change a little bit is this part of my function, the one that's most restrictive, okay, in different spots. So I can start at 0, but I got to go and make a skip at 3 because of my non-removable discontinuity. Are we doing okay with that? Where it's 0 on the bottom. Okay, where it's 0 and I'm dividing it, it doesn't work. Same idea for B. So go ahead and get after B and get after C if you haven't already. Okay, go ahead and get those done. And do the actual compositions. This don't do the domain itself, but do the actual compositions. Because I'm going to ask you to do this. People are like, oh, you just wanted the domain. I want to see the compositions and the domain. Okay, or the additions and subtractions and divisions in the domain, I should say, not the compositions. We'll get the compositions next. Okay, be complete in your solutions. Be complete. Okay, so hopefully we're starting to see that, and that is repeated domain. And the top part, even though I'm putting them together the way I am, that domain is kind of my theme. But now, no, we're good. Okay, go ahead and do the division, and now I'm going to have you do the reciprocal and see if there's a difference, okay, for the domain. Division and the reciprocal. See if there's a difference on those two as we step through. Now, I'm f divided by g. So f is 1 over x minus 3. G is the square root of x. Now, when I'm doing this, I got to be careful as I'm going along, and that should be an equal sign. But I'm going to put this 1 because a division by a value is the same as multiplication by its reciprocal. So I've got that going on, and that should have been an equal. Okay, because I just multiplied by the reciprocal to come up with that value. And now, I'm looking at this, and I've got the square root of x on the bottom as far as my domain is concerned. I know it's not pretty right now, and I know I got that square root there. I can multiply by the square root of x top and bottom as I'm going through. It should be right there, but if it's not, we're just going to put it in. I'm going to multiply by the square root of x here to get my function so it looks nice there. Okay, and that's all I'm doing. So now I have it all nice and taken care of, but remember, my domain is decided by the original way the function was written. Okay? The original way my function was written is, first of all, this can't be 0. Okay? So the square root of x, so it's got to be 0, x has got to be greater than, and it's just got to be greater than 0. It can't be or equal to because it's not in the denominator, it's in the denominator, it's not the numerator. And then my other restriction, as I'm looking at this, is that at x minus 3, well, x can't be 3 either. Okay? As I'm stepping through this. So I'm looking at this. I no longer have my bracket at 0. Okay, so it's open at 0, but then the others are okay. Are you okay with the change in my domain? Okay, now let's look at the reciprocal of that. And I've got that set here, so if I set it up, I'm like this. Remember, this is reciprocal, the same thing I did before, multiplication by something I'm dividing. Okay. Now, I no longer have this in the denominator, so now it can be 0. And this can be 3 as I'm going through. But I still have this. I can have it 0, but remember the original function had this in the denominator, okay? Because it was there originally when I saw it, I've got to make sure that restriction is upheld, and I keep looking at it there, okay? Questions on how I'm deciding my domain, deciding open and closed on my domain, and putting in the removable, the non-removable discontinuity. We're okay? All right. Now, we got compositions of functions. Okay. This is what I got rid of. As we're going through, make sure you recognize notation differences. That composition of function has that open, like a degree sign looking thing. Okay, or you can say it's a fog or a goff. Okay, the composition of function as we go. But let f and g be two functions such that the domain of f intersects the range of g. The composition of f of g, denoted f with this open circle, that's pronounced of, is defined by the rule f of g of x is equal to f of g of x. So we place g of x in to the function f wherever we see x in that function. And that's all we're doing. Okay, so the composition of g of f denoted by that symbol is defined similarly if we reverse it in a similar manner. In most cases, g of f and f of g are different functions. Okay, so language of algebras, function composition is not commutative, but there's a property when they're the same type function, and we'll get to that. X must be in the domain of G, and G of X must be in the domain of F as we go through and we talk about how we're putting it together. But let's actually practice one. Or in your cases, remind ourselves how to do it. Okay? So wherever I see, I got my function f of x, e to the x. Okay? That's my f of x function. Wherever I see x, I place in my g of x as my x value. Okay, that's what this means when I do that. So my next step, if I just kill it, yeah, I'm placing my g of x, so this is my g of x value. My g of x value goes in as if it is my variable x. Okay, and that represents what I'm plugging into x. Okay, since it was e to the x, wherever I saw x, I put in the square root of x. So I'm done with that composition. Okay, you all right with what I did? Yes or no? Now, keep in mind, e to the x power has a domain from negative infinity to infinity. But the square root of x has a domain from 0 to infinity. So as I'm stepping through, it's got to be greater than 0, or I go 0 to infinity like that, as I talk about my domain of my function. Does it make sense how I'm finding my e to the square root of x power? Okay. You guys do the other composition, the g of f of x function, where you go g of f of x, where you take your g function and you place the function of f of x in for x where you see it in the g function, in the g of x function. So wherever I see that, I just have it. It's quite simple and straight, so it's in the inside of my square root. Now I gotta wonder, is e to the x power ever less than 0? I mean, what's the exponential function look like? You know, what you're seeing, what it looks like for there. So this should be defined on all reals, or from negative infinity to infinity. My notation I should probably describe. It's set builder notation. X such that x is contained in all real numbers. Okay. I know that you guys in the past have had x's, you know, something with the r and everything, but this is the proper notation if I use set builder. That x such that x is contained in all the real numbers. Set. But we'll look at it in our notation that we were working with here. It's negative infinity to infinity. Now, with the composition, I want to talk about the two functions I've got, okay, as we're going. And I think I'm missing something. I had something else in there. Oh, yeah, I have the functions. So I had f of g of x up here, and that was equal to e to the square root of x. And actually, that should have been red. Let's make that red. And then this other one was g of f of x equal to the square root of e to the x, as I look at that function. So these two functions are different. Okay. Now, how would I have been able to know if they're the same function after I graph? I mean, you can tell it better if you have a color calculator versus just the black and white one? How would I know they would be at least a hint of the same function? Miss Tim? They would be the same line. And actually in the color calculator, the line would change. Like for this, I have red and blue. So if they were exactly the same function, it would go from the red color to the blue color because the second one would graph over it. And the black line calculators, I can't see that. That's one of the cool things about seeing that color calculator. Some people don't think it's worth that $30. I can't even tell you how neat it was when I got one. I was like, ooh, my wife was like, yeah, whatever. Okay, math geek. Okay, but I was like, look what it does. Okay, all right, it was fun. But it can be seen that the graphs, these two spots here where they cross, are the only two places that they have anything in common. Okay, those values. And it can be seen from the graph the two functions that numerically are different except for those two spots. So they are different functions. Are there any questions? We're doing okay? Compositions? Okay, find the domain of our compositions. Let's look at example 3. You guys do A and B, please. I want you to be thinking of A and B. Actually, I'm going to do A with you. You guys do the composition first, the first composition. We'll talk about those domains together. Let's talk about our domain. Okay, so I got my composition, and some people are like, geez, boom, what's the deal? It's the square root of x squared minus 1. I mean, it wasn't that bad, right? Remember, x squared minus 1 has got to be greater than 0 or greater, right? So where is x squared minus 1 greater or equal to 0? Okay, now I want to talk about that as the graph itself. Okay, if I look at x squared minus 1 as a graph, are you guys okay? It's a parabola with the vertex slid down at 0, -1. Okay, and that when I'm looking at this, I would have two zeros, one at +1, one at -1. You okay with that description of that graph as I step through it? Okay. So if I'm looking at that graph, I'm looking at this. Okay. There's a reason for my insanity right now. Okay. Just go with me for a sec. Right here, from -1 up, it's 0 or positive. Are you in agreement? From a +1 up, it's 0 or positive. And I'm talking about my ranges, okay? Because you got to keep in mind, I'm looking at my values as I'm coming in, and I'm looking at the fact that I have to have a result of x squared minus 1 that's 0 or positive. I can't have a negative value because I can't take the square root of it. Okay, if it was a cubic root, this would be null and void. I wouldn't even be worrying about it, right? So as I'm looking at this, from -infinity to -1 works in this graph. And from +1 to infinity works in this graph when I'm talking about it. So that's why I'm talking about my domain that way. Okay. Now, I kind of get it kind of clunky talking about x squared minus 1 and what was positive on that, or 0. And we're going to learn about that with something called sign charts and how to make that connection eventually. Okay. So this is right now what you know. I mean, you could probably reason it out, but that's where I'm going with my defined domain on this function. Okay. Are there any follow-ups with it? Questions at all? You guys have B. It's not as nasty. Go ahead. Thank you, Ms. Tillman. It's not so bad looking left. We had a seating chart change in class, and we have people that are seatists or sidists. They had particular positions they liked in class. I was trying to break them of that particular ilk of interest, I guess it would be. The interest of sitting someplace in particular. Okay. Now, I'm going to put the square root of x into x up here. So what's the square root of x squared? X. Okay, so I've got that going, so I got x minus 1. But keep in mind how we built this new function. The restrictions that the square root of x brought in are restrictions I have to consider in the function. Okay, so I've got to make sure that my domain, as I'm going through, is coming through here. So that's why it goes from 0 to infinity and not negative infinity to infinity. Because the restriction of the square root of x is the thing I must follow. Okay, that restricts my domain more than anything else. Okay, and I only know that based on the things that created the function. If I was willy-nilly unaware of what created the function, and I looked at this and I would say, well, you know, I've got this new function, x minus 1. What's the domain? And we know that as a linear function from negative infinity to infinity. Everything works. Okay, but because we know what pieces made that function, that composition, we have to go back to the most restrictive part of that domain. Okay? Now, let's talk about what these graphs look like. I like that one on the left. It looks like someone drowning a little bit. Okay, lightly I like that. I mean, I know it's sick and wrong. But the little arms, can you see the stick figure arms going up there? Help me, I'm drowning. Okay, sorry. Bloom's just a sick-minded human being. But look at the graphs. These are the graphs that should come up when you graph these two compositions. Okay? At least if I ask you to graph them based on our domain we defined, this is what they should look like. Now we got some practice. I got on page, I think it's page 49 on your next page. You guys have some practice ones there. I define the functions f and g. I want you to practice the composition of f and g and the composition of g of f, and look at the differences there. Okay? Composition of f and g and the composition of g and f. I'll explain myself in a second. Y'all got this, right? This composition right to here. Why am I doing that? Y'all got that first part. Why am I multiplying by the square root of x plus 3 and the square or divided by the square root of x plus 3? It's a form of 1, just to give you a hint. What am I trying to do? Yeah, get rid of that square root on the bottom. And I've got to multiply by a value that will assist in getting rid of the square root. Okay, so that's why I'm multiplying by what the difference of 2 square factor. Okay, it's a factor that's set up by the difference of 2 squares. So the square root of x times the square root of x is just x. the inside-outside terms would knock each other out, and then I'd have 9, okay, as I'm going through this. Okay, so that's what I've got. You okay with where I'm going with my function? So I made it all pretty. I took that square root out from the underneath. Okay, now let's talk about my restrictions. Okay, I can't have the square root of x minus 3 can't be 0 together. Okay, so if that can't be 0, okay, as I'm going through, where did I hide that here? Okay, if I can't have that be 0, sorry, I put my domain on there, but if I have this here, x can't be 9, but it's also x has got to be greater than 0, okay, as I'm going through. But I could look at it as the square root of x minus 3 has got to be greater than or equal to 0. I should say it this way. That this can't be 0 because of the bottom. So I got the square root of x is equal to 3. Okay, it can't be 3, so I can't, if I square both sides, I'm going to have x cannot be 9 as I go through. So x can't be 9. That's how that happened. I can look at it this way, the way I do this. Okay, or I could use it separately the way I do this, and still x can't be 9. So it's your choice as you go through it, okay, to make it happen like that. The other thing that x has got to be greater than or equal to 0 because of the square root, okay, no matter what, as I'm going through. Okay, and it's got to be, because it's on top as I'm going through, but I can have that x be 0 because that doesn't make my denominator 0 all by itself. That's why I can have it or equal to. Does that make sense as I'm going through? So I can have it x greater than or equal to 0, and this is where I find 9, and this is my domain here of my function. Questions, clarification-wise? Doing okay? Okay. Try the other one, g of f. G of f. And talk about that restriction. 2 problems ahead. What, they caught you in the hallway wandering around and said you had to go back to class?
No, I came right back.
Okay, I'm just giving you a hard time. It's going okay. It's making sense. I mean, the drowning person aside isn't making sense. But you put a little head on there. I mean, that's pretty... Second round, I get it. I know. Now, is the recall of composition of the functions, you guys remember them painfully, okay, as we're going, or is it kind of good that we're going through this? Make sure, if you've got questions, I'm trying to give you a pause and stuff, and don't worry about whether I'm taping one way or another. I care less that this is on it. The people at home have the same questions, so don't even worry about it, okay? When I'm doing this, again, g is the square root of x. So this is inside the square root, right? So when I'm looking at this, you know, formally, that's what I've got going on. But the square root of 1 is just 1, so I get that coming out of this. Okay? Are you okay with what I've got with my function? My composition as we're going through. Now, can I have the square root on the bottom? I mean, technically. And notice the difference in these two. This one I had it just the square root of x minus 3. This one I have the square root of x minus 3 together. So that's why I'm about to do this. I'm going to multiply by a form of 1. But I did not change the sign that's with the 3 here because the difference of 2 squares won't help me because the square root is 1 factor. Okay? So I'm going to multiply that out, and I'm going to find out that my next step is just going to be coming through there. And I've got the square root of 3, square root of x minus 3 over x minus 3. So my function's all pretty. I don't have a square root in the bottom. But it's also helpful because after I do that, I know x can't be 3, right? And I also know that the square root of x has got to be greater than or the square root of x minus 3 has got to, this has to be greater than 0 as I'm checking out my function. It's domain. So that's got to be greater than 0. And I put it as greater than because of that restriction right there. Okay? X minus 3 cannot be 0. Okay, so first of all, I know it can't be 3. So x has got to be greater than 3 and able to make it 0 or positive on the bottom. But I also know it can't be 3 as I'm going through. So my domain, as I step through that, and I guess I did that work there, is 3 between 3 and infinity. Are you okay with your domain and the restriction on it? And that's the last one we'll do today because I don't want to rush the last one. Okay, because I know it'll take some time. Folks, thanks for your time. I really appreciate it. But make sure you're checking your answers. If you notice a discrepancy on the answers, just talk to me about it. I'll try to get those changed as we go through. But I appreciate your time. Keep it up.